So students, in the last video we have stopped at something about the class diagrams that we studied what are the classes, what are the operations, what are the attributes, and then we have seen a simple diagram depicting what is the class diagram look like. It has three sections. One is the class name, the other is attributes, and last is the operations. And we also have seen that the class can ideally is to do its complete job by itself with the help of the attributes and operations, but sometimes it happens that the class uh, cannot do its work uh, fully because of certain constraints. So in that case, there is something called class responsibility collaborators modeling, CRC modeling. A CRC is really a collection of standard index cards that represents classes. These cards are divided into three sections. Along the top of the card, you can write the name of the class. In the body of the card, you can write the class responsibilities. On the left are the collaborators. On the left and on the right are the collaborators. So in general, what happens here is you are having you have a class diagram, right? You know what is a class diagram. So in the class diagram, let's remove something called attributes, right? So this is the class name, and these are the basic operations that the class needs to do, right? So I have operation 1, op1, op2, op3, op4, and op5. Suppose these are the five operations the class needs to do. Out of these five, these three operations can be done by the class itself, right? Now for these two, this class need, suppose, class 2, and for this it needs class 3, right? So these two things should also be mentioned in the collaborator diagram. Okay, so if I'm not mentioning anything in this column, that means these operations will be done by the class itself. And against op4 I have written c2, and upon op5 I have written c3. That means in doing operation 4 I will need the help of class c2, and in doing operation 5 I will need the help from class c3. The similar thing has been done here as exemplified here. It says the class name is the floor plan, that there is a description of the class, then there are responsibilities defined for that floor plan class. It defines the floor plan and name and type, manages the floor plan's positioning, scales floor plan for display, and scales floor plan for display. Okay, suppose they are written two times, I guess. So now incorporate walls, doors, and windows. The floor plan will show you the walls, the doors, and the windows, but actually floor plan cannot have. We need we need the information from some other class. So the class that is being used is called the wall class. And likewise, there should be something called position of the video cameras. Yes, the floor plan will display the video cameras, but this information about the video camera and the positioning should come from a camera class. Okay, so these are the two classes with which the floor plan needs to collaborate in order to actually implement the complete floor plan in the actual sense. So this is what is known as class responsibility and collaborators. So it has a class. It mentioned some of the responsibilities that it can do it by itself, and it's all mentioned the collaborators with which the class needs to work along to implement certain other responsibilities. Now the collaborations, the classes fulfill their responsibilities in two ways. First of all, a class can use its own operations like op1, op2, op3 that we have seen in our previous example to fulfill the responsibility, that is called the particular responsibility, or the class can collaborate with another class. We have seen this in our previous examples also. Flow plan, these two things. Okay, now to have in the identification of the collaborators, you can examine three different generic relationship between the classes. Okay, so you want to identify what is the relation between the classes that falls under collaboration. There are three type of generic relationships. The one is called is part of. is part of is the first relationship, has knowledge of is the second relationship, and depends upon is the third relationship. We will see some examples here. Suppose this is an example of a video game that is designed for playing a game which has a player, and each player has a player head, body, arms, and legs. So all classes that are part of an aggregate class are connected to the aggregate class via is part of relationship. So you see here, this is the player class. This is the player class, and this diamond actually shows you the aggregate function. Okay, aggregate function. So I hope you have studied this in your DBMS or database management system classes, that how to represent an aggregate function when you draw an ER diagram. So this is an aggregate function. So this player class gets information from the head, the body, the arms, and the legs. So if you have an aggregate function, all those classes that are connected to this parent class player via the aggregate functions. So this player class depends this class is part of an relationship. Okay, the player body is a part of the player, but in the same way, player arms, player head, and player legs are the part of the player. So all these classes are related to the player class with the help of is part of relationship. And for implementing this player, he need to collaborate with the player head, the player body, the arms, and the legs. Okay. Likewise, you have something called has knowledge of. That means a class in its implementing into its work should have knowledge of the other class. Suppose there is something called a determine sensor status is one of the responsibility. So in that case, the determine sensor status responsibility is an example of a has knowledge of relationship. That means a sensor S should determine the status and then implement the things. Right? To implement to raise an alarm, the sensor should know the other sensors. Okay. So this is the sensor class. It should depend upon the data that is being given to you by sensor 1, sensor 2, and sensor 3. So whatever this sensor class will raise, whatever thing this will display, it depends upon the various information that has been provided by the other class. But it cannot say that this will not work if this thing won't happen. So if this thing goes down, the data related to this won't display, but the data related to other classes will work. Okay, the functionality will work. So the display the sensor class will depend upon S1, S2, S3. Okay. Likewise, if you say and you want to understand what is the last relationship, that is called has knowledge of. The depends on relationship implies the two classes have dependency that is not achieved through has knowledge of and is part of. Okay, so this is what it means. So player head must be connected to the player body. In playing a game, you actually know that a head lies on the body itself, until unless you are playing something which is a very violent game like zombies where people can move without head. So it is an extremely dangerous games. So in general, when you play a football or play a hockey or a cricket based game, the player head must be connected to the player body. Yet each object could exist without the knowledge of another. That means the head actually should not know what is the class called body, because all these classes, head, body, arms, and legs, they are independent classes, isolated classes, but they should provide certain information to another. An attribute of a player head object called center position. So there should be something called center position. Okay? There is something center position is determined from the center position of the body. So the head, and this is the body. The head this is the center position of the body. So head should be in line with the center position of the body. So this attribute, center position of the head, should be in some way uh, related to the center position of the class called body. Okay, so that's what we say, that player head depends upon the player body. If the body turns or leans down, the head should also leans down. Okay, it could not say the head lies up and the body becomes this way. Center position changes, the head should also change accordingly. Okay, so this is something called depends upon. Okay, so these are the three different type of attributes, or you can say relationships, that actually the collaborators, when we design collaborators, we need to understand is part of, depends upon, and has knowledge of. Likewise, there are some associations and dependencies, like it's shown here. Each wall can have either a wall segment, or it can have a window, it can have a door, right? So I can represent this diagram to show multiplicity. Say one wall, if I write one here, that means I am talking about one wall can have, write one double dot star, that means either it can have one wall segment or it have multiple wall segments. Likewise, I have written 0 dot dot star, that means I have mentioned here either this wall has a no window or it have multiple windows. Likewise, I have say this wall can have no door or have multiple doors. Okay, and then it can also have some dependencies which say that to in display window of a control panel, and there is a camera class. So the display window will access the camera using the username and password, and once this is accessed, this thing will then display the camera feed. Okay, until unless you this access is provided, this display feed won't come here, right? So it depends upon this access. These are the dependency of the display window or the control panel class with a camera class. Okay, so this was all about the class based modeling. So in our next video, we are going to discuss about the flow based modeling, and in addition to flow based modeling, we are going to learn about the behavioral modeling as well. So that will complete the requirement engineering part. Then we will move forward with the matrix or implementation of the software sizing approach in our next video. Thank you very much.